In a previous video, you've looked at several examples of synthetic and natural polymers, but more importantly, how they can release a small molecule like water as a result. Proteins are an example of natural polymers joined by amide links. The monomers that compose proteins are known as amino acids, and there are only about 20 different types. However, it's the combination of these amino acids that result in the many different types of proteins. Let's look closely. The combinations of the 20 different amino acids, that is, monomers for our proteins, determine the structure and hence the primary function of the protein. However, all amino acids have a few things in common. All have an amino functional group, which is usually drawn on the left, and all have a carboxyl functional group, usually drawn on the right, which are both attached to the same carbon. This is known as the alpha carbon. The other carbons form the chains, which also then determine the final protein structure. So let's build a small amino acid sequence. The names of amino acids are usually abbreviated to the first 3 letters, so this will be our sequence. When lysine bonds with cysteine, the OH from the carboxyl group, which is attached to the alpha carbon, comes off, and the hydrogen from the amino group attached to this alpha carbon comes off. These join, and these form water. These side chains remain unaffected. If aspartic acid is added to this polymer, the OH from the carboxyl group attached to the alpha carbon comes off, and the hydrogen from the amino group attached to this alpha carbon comes off. This joins here, and these form water. These are amide links, but since our monomers are amino acids, they are known as peptide links. Therefore, this sequence of amino acids is known as a tripeptide.
Wow.
Multiple peptide links result in a polypeptide, and when there's hundreds of thousands of these amino acids, they make up a protein.
Wow.
So proteins are just huge polypeptides, however still have an amino group at one end and a carboxyl group on the other.